Welcome back to Learning with me, Ms. Killen, here at MPB. We are in our 9th unit. We are looking at our functions. We have been reviewing our linear, our quadratic, and our exponential. Now we've got a new one that we're looking at. It's called a piecewise function. And we are going to be able to say that we can understand and graph a piecewise function. We're looking at F-IF.2 and 7b. So let's go ahead and look to see what this piecewise function is. So here we go. The function we have learned are our linear, which is a straight line. We've looked at a quadratic function, which is a parabola. We've looked at an exponential function, which is curved lines. Now we've got a new one. This new one is a little different. We are looking at the piecewise function. It's a function made of pieces based on different rules for domain. Same as always, domain is your input, your range is your output, and it still has to pass the vertical line test. But one thing that I want us to understand, when we talk about a piecewise function, the main word that we're looking at is piece. It's a bunch of pieces that put together to make the whole function. There's going to be some limitations on my x values. There's going to be some limitations of what can and can't, what can equal and what can't equal. So there is lots of pieces that go into this piecewise function. So here we go. It says a piecewise function. As you can see, there are different pieces that make up the graph. At the different ends of the graph, there will either be open circles or closed circles, depending on if they can or they cannot equal that number. With this function, there are limits or rules for the domain and the ranges. So we see that we have an open circle here as I go this way. And it's an open circle here, but then it's closed here. And then I have a closed circle here, and then it's an open circle here. And then at 2, it's an open circle, but then I'm going down. So there's multiple pieces that go into making this function. All right, so a piecewise function. There are different types of examples of piecewise functions, so I want us to look at those. So our first example is traveling different speeds down the road depending on the speed limits. Some may be 55, some is 35, some is 75. Depending on where you are, depends on the speed limit. So that could be, let's say, while you're in Mississippi, you can do 55, but as soon as you hit the Alabama line, maybe you got to drop it back down to 45. So there's a different limitation to that speed. So our second one says getting paid hourly at minimum wage, then get paid overtime. So you're going to get a different amount when you get paid overtime. So let's look at the third one. A mechanic charges $50 for the first hour of labor and $45 for the initial. So that means that first hour you're paying $50, and then the next one you're paying $40, and so forth and so on. So there's a different piece or a different limitation depending on the money. So the fourth one, a phone company offers the first 100 text messages for free. After that, each additional text message is 10 cents. The fifth one says a taxi cab company charges a flat fee or initial fee of $3 plus $2 per mile for the first 10 miles. After 10 miles, the rate goes to $1.50 per mile. So I'm dropping the amount of the miles depending on how far we've already driven. So let's look at this last one. A gym offers the first month for $10. After that, each month costs $30. So after that first month, it's $30 for you to have your membership. So I've got different limitations depending on what we're talking about, depending on what the amounts or the numbers that can be, depends on those limitations. So let's look at some more. It says each part of the function has a defined domain, value, or rule. Now, let's look at the piecewise function notation. Notice we have our f of x, which is just the same as y equals, but now I have x squared minus 2 when x is less than or equal to 0. My y equals a number when x's are less than my 0, or they equal. So then, for my y's, when I have 2x plus 1, when x is larger than 0. It can't equal 0, but it's larger. My y equals a number when my x is greater. So it would look like this. So if we look, so right here I have a closed circle. It can equal, no, excuse me, it's open circle. It has to be greater than my x. My x has to be greater than 0, so therefore I'm going to have that open circle. But right here it says it can be greater than. So or equal to. So depending on what type of inequality symbols, depends on if you're going to have an open circle or a closed circle. So you got to make sure that you pay attention to those like Ms. Killen had to. You got to make sure that you're paying attention to what that limitation is for that part or that portion of the piecewise function. Good job. Now, you may be saying, Ms. Killen, what is all of that over there? That is how we're going to learn to put it into Desmos. You mean, Ms. Killen, we're going to let Desmos graph all this? Absolutely. Because if you tell Desmos exactly what to do, just like any computer program, you have to give them specific instructions and then they can work this. So, let's go. When looking at the piecewise function, you have equations and you have conditions. The equation part is what you see on the graph. The condition is where the graph can or cannot be on the graph. Let's take apart each of these pieces. So when my x values are smaller than 0, I'm going to use x squared. So like, let's say -3 or -10, I would use that portion. So then, if I have my x values between 0 equaling 0 or to 3 equaling 3, I'm going to have -1. So we're looking at 0.5 or maybe 2. We're going to use that -1. So then our last portion, let's do blue, when my x's are larger than 3, I'm going to use that x plus 1. So let's say 5 or 27, I would use the x plus 1, or I would look to that portion on the graph. That's how we're reading those. We use this when my x's are this, or we use this when my x's are this. They're different pieces of the puzzle that put together to make the whole function. All right, so let's look. All right, it says the technology tools. Let's see how we can put these types of functions into our calculators. Now, my TI-84, you have to put each part of the piece with its condition into the calculator. That takes a really long time. Depending on if you have a timed test or if you have that end of the year test, you only have a certain amount, it can take a long time. Now, we have a video to show the TI-84 Plus's different feature for this piecewise function. But the one I'm going to show today in this video is going to be my Desmos. All right, so we're going to try x squared when x is smaller than 0, -1 when 0 is less than or equal to x, which is less than or equal to 3, and x plus 1 when x is greater than 3. So we're going to do Desmos. So let's go ahead and pull Desmos up. So for my first thing, what I'm going to do is I'm going to put in how to do this for my piecewise function in Desmos. So I'm going to put first my keyboard. I'm going to put y equals. Now, I've got to put a different type of grouping symbol. So I'm going to go to my A, B, C down here at the bottom. And over here under my y is I have this different type of bracket that we've not used yet. So I'm going to use this different type of bracket. You must have this type. Now, to put these piecewise functions in, you first have to put your limitations. So my limitation is x, or let's go back to my one, x, and it is less than 0. Then after that, what I have to do is I have to tell them what I'm using when I have that limitation. So I'm going to use my colon sign. So let's find it. There it is under your uppercase Z. So I've got my colon. So then I'm going to put, go back to here, x squared. So there's the first part of my function. So I'm going to put a comma, and I'm going to put my next limitation. So my next limitation is 0, which is less than or equal to x, which is less than or equal to 3. And I'm going to put my colon, so I have to go to my capital letters and put that colon. Then I'm going to go back and I'm going to put what I use when I have that limitation, which is -1. I'm going to put a comma, and I'm going to put my last limitation, which is x is what? Greater than 3. And I've got to put that colon. And then for that, I'm going to put x plus 1. And I have to now end all of my different limitations and my conditions. So I'm going to go back and put, you have to put the up arrow to get the ending grouping symbol. And this is my piecewise function. All of my x values that are less than 0 are up here. But when I get to 0, it goes down to here when I have that -1. So then I go all the way over to 3, and once I get to -3, then I come up here and I have my different part of my function that I'm going to use. So you've got to make sure that you put your condition or your limitation in first. Then you tell the Desmos, when I have this limitation, this is what you use. When I have this limitation, this is what you use. So the more that you practice putting these limitations into Desmos, the easier it'll become. So let's go back. All right. A real world example. Tax brackets. Everybody pays taxes sooner or later. The more money, different percentage that you pay. So the more money you make, the more taxes that you pay. The rule changes based on the input. The input is how much money you make. It can also be called sub-functions, each with its own domain. So those limitations that we have can be called its own domain. That's when this part of the function, you use this. So it would be that sub-function. Piecewise functions can be continuous. There's no breaks, there's no jumps, there's no holes. You can draw it without lifting your pencil. It can also be a discontinuous, meaning there are breaks, there are jumps, and there are holes. The ones that we put up on the board, you can see where you jumped around, or you might not have a certain number that could be part of that function. So that's when it's talking about the continuous or the discontinuous. All right, a discrete function is considered a type made of separate disconnected points. It is a type of discontinuous function. So we notice that we have the straight line, and it can include this 1, but it cannot include the -1 because it has the open circle. So depending on how your circles are open or closed, depends on if they can be or they cannot be included in this different function. I have my limitations. I use x plus 2 when x is less than or equal to -1, and I use x squared minus x plus 2 when x is greater than -1. So you've got to make sure that you're looking at all of your conditions depending on what you're going to use. All right, we have this function. Notice the information given. So I'm giving my limitations. I am given what I use for those limitations. So what we're going to do is we're going to put this into our Desmos. So everybody go ahead and pull up Desmos. I'm going to pull it up here and watch and see what I do. All right, so here's my Desmos. And I'm going to go ahead and put in these different limitations and see how it graphs. So the first thing I'm going to do is I'm going to put y equals, and I'm going to put my bracket, and then I'm going to put my limitation of x is greater than or equal to 0, and I'm going to put my colon, and I'm going to put x squared plus 2, comma, then I'm going to put my next limitation, which is x is less than 0, and I'm going to put my colon, and then I'm going to put x minus 7. Oops. And then I have to close that bracket, remember. So here is my different. You have to pull it out some. So I have open circles, I have closed circles, depending on what my limitation is, depending on how this graph looks. So you've got to make sure that you are looking at those limitations. Good job. Let's go back. And there we go. There's how we had it. That's exactly what our Desmos looked like. All right, so let's do some practice. Rayan and Abby are going to the fun zone in their town. They can skate for the following prices. 3 hours or less is $15. Between 2 and 5 hours is $25. And 5 or more hours is $30. Now, write a piecewise function to represent the scenario. Remember when we have open circles and closed circles. So let's go ahead and write these up here. So I'm going to, instead of writing y equals, I'm going to put f of x. And let's get a different color that shows up a little better. So I'm going to put this up here. So I have f of x equals. Then I have my bracket. If you can't draw the bracket, just put a squiggle. I promise you, you are not going to make anything wrong if you just put a squiggle. So some people can't draw the bracket. It's okay. So here we go. So I have my bracket, and I have 15 when 0, meaning my time, is greater than x, which is greater than or equal to 3, because it says 3 hours or less. All right, so then I have 25 when I have 3, which is less than the time, which is less than or equal to 5. Or then I would have 30 when, didn't put my ends, 5 is less than x. And since we just can't leave this infinity, let's just say 10 hours. Because who can skate for 10 hours? I know I can't. So now that we've written this, I can see $15 when my time is between 0 and 3 hours, and it can equal 3 hours. $25 when my time is between 3 hours and can equal 5 hours. And then $30 when my time is between 5 and it can equal my 10 hours. So I've got my conditions and what I use when I follow those conditions. So this is how we're looking at building those piecewise functions. All right, time for you to master. Make sure that you read the passage and notice the information given in the passage. So here we go. Use the following piecewise function to match x values with the range values. So I want to show you how to do this, and then I'm going to let you and your partner or you by yourself do this. So here we go. I've got 2x minus 1 when negative 2 is less than x, which is less than or equal to 4. I'm going to use x minus 1 when x is less than or equal to negative 2. And I'm going to use negative 3x plus 8 when x is greater than x, or 4, excuse me. So I'm going to do the first one for you, okay? I want you to see how we're doing this so you can do the rest of them. So I'm going to do the first one, then I'm going to let you finish the rest of them. So we're going to start with number 5, or negative 5. So where does negative 5 hit with these limitations? Well, negative 5 would be where? It would be here. Negative 5 is less than negative 2. So I would say here I am using x minus 1. So that is how we are working these problems. So I want you to go ahead, you or you and your table partner, go ahead and work the rest of them. Once you get them done, do your x and your g of x. Come back to me and we'll see what we got. All right, so now that you've had time, let's see if my work looks like your work. So here we go. So I have negative 2. I can equal negative 2, so I am going to use my x minus 1. All right, so when my x is 0, where would that be? My x is 0, it's going to lie between negative 2 and 4, so I'm going to use 2x minus 1. So when I have 2, when my x is 2, where does that come in? It is between negative 2 and 4, so I'm going to use 2x minus 1. So when my x is 4, when it can equal 4. Now, a lot of people say, oh, negative 3x plus 8, but I can't use that one. It says my x has to be bigger than 4. So when can my x equal 4? You got it, 2x minus 1. And then what about when my x is 8? It's going to be the last one, negative 3x plus 8. All right, so now let's do this g of x. Let's see what we've got with g of x. So negative 16, where would negative 16 be? Negative 16 is going to be less than or equal to negative 2, so I have x minus 1. Well, what about negative 6? Same thing, x minus 1. Negative 3, yep, x minus 1. What about negative 1? Negative 1 is going to be between negative 2 and 4, so I'm going to say 2x minus 1. What about 3? Where is it situated at? 2x minus 1. Now what about 7? Yep, that last one, negative 3x plus 8. check your work, check my work. Does it look the same? Did you choose the same ones that I did? Because where my x's are, you've got to make sure it follows between those limitations is the part of the function that you use. So that's what we're looking at when we see these piecewise functions. We don't want to forget different in piecewise and other functions graphing. Remember, piecewise function has the pieces of the graph. All right, what's the conditions and what do they look like for the different pieces of the function? We also have the continuous and the discontinuous functions, what they look like and how we look at them. We have our discrete functions, and then we also talked about our subfunctions. So we need to make sure that this is yet another function that we're putting together with our other groups that we have, our linear, quadratic, and exponential. I'm having a great time learning with you guys. I'm so glad that you chose to come and learn here with us at MPB. I am Miss Killen. Have a great day.